Yeah, thank you for the introduction. As you already said, I'm Claus, I'm from Vienna. It's my first time here at PYCON UK. It's a very nice event, I have to admit, although this hall is also a bit intimidating, I would say, but it's certainly the coolest one I've ever been. And also slides, you've seen them? Okay, still there, that's good. So we are going to talk about implementing custom containers. Just to be sure, it's not a Docker talk, but we're going to talk about Python collections. And why are we doing this? Well, choosing the right container or collection is a very important design decision, which greatly influences how your code will actually look like in the end, and therefore knowing how you can represent your data and also how to implement custom containers or classes is, I think, rather good to know. And personally, I am not a software engineer, I'm a data scientist, and through Python I kind of, discovered my joy for programming. Before that, I was primarily using MATLAB. It was more a necessity, programming to achieve my goals, but through Python I decided, oh wow, hey, that's actually pretty cool. And one of the things I found rather interesting is how containers are implemented, how all these dunder methods work together, and therefore I thought maybe it's interesting to share some of these things here with you. There are, of course, a lot of approaches to this topic, and it's also a very wide area. So, to be clear, we are not talking about metaprogramming or anything related to this. It's really about you are in the situation where you use a built-in type, but you have a feeling that, okay, maybe it does not really suit your needs, and the question is, what is the smallest, next non-trivial step? And this is what we focus on here. Taking a look at two examples that are related to how I represent my data and also how to implement a custom container type. So before we go into the details, we're going to talk a lot about dunder methods. So if you're not familiar with this notion, we have all these double underscore methods, and since double underscore is a bit annoying to say, you can use dunder in short. And we are going first to clarify what is a container and what is a collection. Maybe I will use it rather interchangeably, but in Python it's rather clear what is meant by by which of these things. And then we will go into customization, taking a look at two examples. So, what is a container? Very sloppily speaking, a container is an object that holds other objects, and a collection is also a container, but it is sized and it's also iterable. In Python, if you want to ask something whether it's a container, you have to check whether it has a contains method. Dunder contains, so you can then ask whether some item is part of this thing. So if you write item in list or so, then internally it will trigger a dunder contains. On the other hand side, if you want to check whether something is a collection, it has to be a container, but in addition it needs to be iterable and it needs to be sized, so it has to support dunder len. Of course, maybe this might change somewhere, it's highly unlikely, but here we are explicitly checking for these methods, and the proper way to do that is by checking whether the object that you are investigating is a container or a collection type, and you do this by checking whether the abstract base class that is defined in the collections module actually is supported by what you have here. So if you want to check whether something is a collection or whether it's a container, you just import from collections ABC the container or the collection abstract base class, and then perform your isInstance check. Typical examples of a collection and of course then also a container are tuples, lists, sets, and dictionaries and the like, but not only these. So a string, for example, is a collection as well, because you can iterate over it. It has a certain size, and you can ask whether, for example, hi is part of this string. So it also supports contains things like numbers, none, and the like are not container types. Of course, there are a lot of other things as well. We don't have the time to go into details here, but you should really take a look at the collections module, even if you haven't already. There are quite a few very handy data sets, data containers in there, and even if you are at the beginning not so sure why you might need something like an order dictionary or maybe a default dictionary, I really recommend just copying some source code, play around with it, and sooner or later you will stumble upon a use case and then be very glad that you know that, for example, a default dictionary exists. So, with regards to our objective, namely about data representation, we will take a look at a small example. Imagine we have a study and we have a participant in our data set, and the participant seems to be called Chang Wei, and there are also some other numbers that are related to this participant. Here we read 58 and also 71, and if we take a look, we decide to choose a tuple to represent this, and using a tuple is actually a good choice because it's immutable. Data should always be immutable, and it's also memory efficient because it uses slots internally, so it's not the usual dictionary overhead that you have with custom or with your other class types, but it's actually not that bad to use a tuple to represent this. However, there is the thing that it's not really clear what this data set is about. So maybe you're familiar with Chinese and then you can distinguish first and last name, but maybe you're not. So it's not clear whether this person is called Chang Wei or Wei Chang, right? Of course, here at PyCon UK, you are encouraged to ask for each other's name. So the Zen of PyCon UK, the first rule is don't be afraid to ask for names, and the second rule is also to ask again if you forgot a name. But surely it's a dilemma because the Zen of Python tells us that in case of ambiguity, you should refuse the temptation to guess. So maybe we should fix this. The same holds true for the numbers because they really have no meaning, and it would be good to provide context by adding some information about what they really want to tell us about our data record. Always when I see data that I would like to model, I'm very tempting to think of all possibilities that can come up, and if you then make a sketch, you easily, at least I do, I very likely get lost in over-engineering. But then there is this saying, you ain't gonna need it, so you should keep it as simple as possible. But if you see that a plain tuple is too primitive, and in this case it is because we don't really understand what this record is about, maybe it's time to go one step further. And we can do this by adding contextual information. And if you want to add some contextual information, for example, by changing the representation of your container, what you need to do is you need to implement dunder wrapper and dunder string. So dunder wrapper is called if you just want to display an object in the prompt, for example, and dunder string is called if you turn your object into a string. And we need both, and the handy thing is that there is already a container in the collections module. It's called name tuple, which does this for us. So we get a nicer representation of the same thing that we had before. So we just import it. You pass the name of the class that you want to come up with. In our case, it's the participant class for our study data, and you also assign field names. So you can have a given name, you have a family name, you have age and weight. And if you take a look at it, now it's much more self-explaining than it was before. Yet, if you saw the talk before, I think a few hours ago, it said docs or it didn't happen, right? So there's still some important information missing. Namely, we have no documentation. And in our example, this is especially important with regards to the numbers, because although we now know that 71 is weight. It's still not clear which units we're talking about, right? So we need a way to look this up, and a very natural way is to put this in the docs. If you are happy and are working with at least Python 3.5, then this is very easy to accomplish because you just directly assign to the doc attribute. So dunder doc contains the doc strings. We add a doc string for our class itself, and then also for all attributes. So this was very easy. There's actually no need not to do it. But the good thing about using a custom class or a custom container is that you can now come up with additional ideas and add additional features if you need them. Of course, only if you need them. But one thing that I usually encounter when working with datasets is that they are never ever complete. So they are usually always missing values, and that's maybe a bit of a problem here because we have a tuple. The tuple is of fixed size. We want all tuples to be comparable. So if we have, for example, a missing value, we need to impute it. We need to somehow support default arguments, and this is actually really easy because when you create it, in the case of the tuple, since it's immutable, we have to take a look at dunder new because this is what returns the object, and then dunder init does the initialization. But new is just basically a function, and therefore it has default arguments, and therefore it has a default attribute, which is called dunder defaults, and there we can supply our default values. So let's take a look. Again, we have our participant with defaults named tuple, and what we do is that we assign the dunder new method dunder defaults tuple that contains default values. And when we do that, we can come up with a participant that only has a name and an age, and the remaining values are automatically filled in. And really, this what we just wrote depends on how many characters you accept, but it was 2 lines. I think it was not so much of an effort. But yet, if we are at this stage that we can gradually increase the complexity of our code, we can also say, now we have default values, maybe we have also other assumptions about our data that we want to be taken care of. And one thing could be input validation, for example. And this we can also do now that we have seen that we can use dunder new to see how the object in the end looks like. We can also try to support some kind of input validation. The thing that I like about having a container type that validates itself is that then I know that at every location or at every processing step this container is used, that certain assumptions are already met. And if I, for example, say that I want to require minimal age, because, I don't know, maybe you are, in your study, you are, let's say, comparing beer or so, they have to be at least 18, let's say. And what you then need to do is that you adjust your new and check if one of the arguments, namely the age argument in this case, is at least 18. If not, you raise a value error. And what you get is then, if you try to instantiate a participant with input validation and defaults object, which is now a bit of a lengthy name, but I think you get it, you will receive a value error. And otherwise, it will work. So, still, it was very, very convenient. It was rather easy to come up with these additional features. And now we have a container type that is pretty capable of solving quite a lot of problems. To sum it up, of course, it makes sense to start with the default container type, but maybe in some cases they are too primitive, and then limit your expressiveness. So you want to come up with a custom one, and then add features like default values or input validation. Something that I like in particular is that you can then add type hints and also static type checking, which opens up a whole new possibilities both in IDEs and also to have nicer tools available when it comes to refactoring, for example. If you often face the challenge of implementing custom classes, you may take a look at the address library, which is very nice. The motto is classes without boilerplate. So if you think what we saw here is something that you encounter frequently, take a look at address. The other question that we were asking is how I can implement or mimic the behavior of a built-in. And as we know that there is this abstract base class submodule, the ABC module and the collections module, all we need to do is that we define our own collection and then we derive from the collection that we chose to mimic. And the example that I would like to take a look here is that we have, for example, some aspect in a data processing pipeline, and from some kind of data set we want to extract all answers. That's a function that we have here, and the situation that you frequently see is that in the simplest case, for example, you have a bunch of CSV files, you want to process each file, therefore you have to read it, you process it, and then you write it back to disk. And a small workflow, a very primitive workflow, could look like this. The problem, or let's start with the good things, it's really simple, it's really obvious what you want to do. The problem may be that if file handling is rather complex, if reading and writing is also complex, it really makes sense to separate this from the processing task. And I bring this example up here because what we actually have is a function that produces a mapping between input data and output data, and we also have a mapping between a data store and the data frame. So in fact we have a number of mappings here, and since we're talking about mappings, we can think about implementing a container that mimics the behavior of a mutable mapping to implement exactly this functionality. So what we need is using the collections module, abstract base class mutable mapping, and come up with our version of reading and writing and all these things. Usually, if you haven't done this already several times, you won't know which dunder methods you need. So the easiest way is just to start like this. You try to instantiate it. Of course, these methods are not already implemented, therefore you will get an error, but you will also get the explanation that if you want something that behaves like a mutable mapping, namely like a dictionary, you need dunder del item, dunder get item, iter, len, and also set item. So all we need to do is that we implement exactly these methods. The example here maybe looks a bit verbose because we need to come up with a mapping that is linking file paths to IDs. This is what's going on in the init here, but then all we have is a get item method which encapsulates our reading of the file. We need a set item which encapsulates how we write back to disk. We need an iter, but iter is rather simple because we only need key value pairs from the input paths. Len is also rather obvious because it's the number of paths we have at our disposal. And delete item is also rather trivially implemented because what we have here is a situation where we can't delete anything because we only want a mapping that maps input data to output data, so there is no deletion here. What you see is that once you have get item and set item methods here, it's rather simple to delete these actions because as a user, if you are working on the data transformation part, maybe you are not in the position to know how you actually read and write this data, and maybe you even don't want to think about this because it's somebody else's responsibility. So you can, in this case, rather nicely separate these two tasks, that there is one expert that knows how to deal with, I don't know what, maybe some complex data queries or whatever, and on the other hand there is one expert that knows how to actually work with the data once it is available as a data frame. And this is one way. Of course, there are many more that you say, okay, somebody is taking care of get item and set item. Maybe the same person is taking care of establishing a mapping between which files or data stores are mapped to which ID in the input side and on the output side. This is what's going on here. Typically, you would delegate this to somebody else. I would not do it all here, but what you then gain is a rather simple interface. So we just say in our example that we have some kind of data input folder which are just called data in, and through glob I collect the file paths, and what I can then do is that I have key and value pairs, and I can literally iterate over it without ever wondering how I really get this data. And in my opinion, it's rather handy to do it this way, because if I'm working on this function part, on this data processing part, I still know how to work with the dictionary. There's nothing new I need to learn. And if I then really have accomplished working on this cool extract all answers of functionality, then I can save it to disk. Again, I don't have to know how I exactly do this. I just process it. And if you take a look at the examples, we have now a data out folder, which produces again the CSV files that represent the output space. And apparently it worked, because we were able to multiply every value by 24, which is of course not a great accomplishment, but it should be a self-contained example. So to sum this up, if you want to mimic the behavior of a built-in, you go to the collections ABC documentation, see which aspects you'd like to have implemented, and then you choose what you need. Then you implement, or then you instantiate this very dummy implementation. It won't work because the required methods are not implemented, but the arrow will tell you what you need to do. Also, a good thing is that all other functionality that you may need, you get is already derived. However, these implementations may not be as efficient as they could be, so you should take a look at that. And if you directly subclass, for example, lists or dictionary, this can be a bit tricky. So in some cases, you may consider the types that are called user list or user dictionary. And as a rather last comment, what you saw at the beginning, that you test against an interface instead of testing against a type, is usually recommended if you want to just support duck typing in your code. So from my side, I say thank you. If you find me around and have further questions with regard to the talk, or want to give feedback or some other ideas, I will be happy to talk to you. And thank you for your attention.